over the last 30, 40 years. And fortunately, in the last 25 years, I had the opportunity to start a couple of startups, mainly in the microprocessors and the internet infrastructure area. So now we're moving from the internet infrastructure to a new era, which is the blockchain era. And this is the topic of my talk. What do you need to do to scale? But you have to look at how to begin first and learn from that and apply that success recipe to blockchain. So my name is Rick Bleszynski. I'm the CEO and co-founder of Splend. This is my third technology company. The previous two was in the microprocessor and broadband. So the previous company that I found before Splend was Bay Microsystems. And I was the founder, chairman of that company from 1994 to 2014. The company is still there. It merged with another company in Silicon Valley. And previous to that, it was Software Microsystems. I was the founder, chief technology officer, board member from 95, and Intel Corporation bought this in 99. Hugely successful company. So what is the difference here? The difference here is that this is, when you start a company during an uptrend of a bubble, it's a lot easier. Right? Even though 99 is not the peak of the bubble, but what's really the challenge is when you start a company at the top of the bubble, and then the bubble crashes, thousands of companies shut down, and you survive. That's the challenge. So how do you survive? Today is the same thing happening. Right? We have 2-3 years of bubbles in the blockchain coin space, crypto space. And today, bubble is one. It's more realistic to me today. So, previous to that, again, I come from the architects, from the technology side, and I have 8 US patents, mainly processors and broadband networking. And this is taught me quite a bit of what do we need to do with the blockchain infrastructures to scale. But scaling is not enough. I have seen technology that scales and very, very sophisticated. Back in the 90s, it's called the asynchronous transformer. It's one of them. 10 years of standard works and so forth that we on the shelf today. What is that? Okay. And the technology we have today is not even as sophisticated as that. So everyone has the same similar vision today, right? We have the standalone computer, we have the internet era. It's fine. And then we're going to the blockchain era right here. So what's so disruptive about blockchain? I don't want to repeat because this is, people have seen this for a while. So transparency is good, immutable is good, but what is disruptive about blockchain is this thing called the decentralized trust through computations. And you all know proof of works is slow today and consume too much electricity and so forth. So that's what's good about blockchain. You can transfer coins from one another without any intermediaries. Who do you trust? You trust the cryptography. That's what I meant by decentralized trust through computation. It's basically transforming the internet into what I call the global network of trust. That's what blockchain is. That's what I think this is disruptive. It's decentralized, yes, immutable, yes, trust, and global network of trust. Okay, there's intermediary that's not into there. So how did we get here? Right? Applying the recipe from the internet era, you have standards and protocols. Standards and protocols, we are going through this today too in the blockchain side, on the stacks right here. So standard and protocols have to work from the application layers, from the session layers, transport layers, network layers, all the way down to the optic layer. They have to scale from the applications to all the way down to the optic layers. Right? So that's what happened in the internet era. Now, standard itself is not enough. Why? Because if you look at the advancement in microprocessors technology right here, this needs to happen together with that. You need to combine this with this get is system level integrations. So I want to ask a couple of questions right now. Intel in 1971 comes up with the 4004. There's 2,000 transistors back there, 2,300. Do you have any idea the A12 chips Bionic on your iPhone or whatever that came out last year? How many? 6.9 billion. What is the size? 9 by 9 millimeters, 83 millimeters. That's right. So this is a very necessary piece of the infrastructures previously. Right? Now, there are specialized processors in the graphics side, in the network side, but it doesn't, I mean, yeah, Intel claimed that they have a security module as part of their memory as a trusted regions beside this, but there is no specialized processor yet for this. This is taken from the previous one. And if you look at this in the 90s, that is the infrastructures that builds the internet. The killer app wasn't there yet in the 90s. The killer app came in the early 2000s, or late 90s. Google, Amazon, Facebook, Netflix. That comes after the infrastructure was built. Right? So there is a lot of similarity that I'm going to keep going back and forth right here, between the internet and the blockchain. So what we think right now, if you look at what I call the final dilemma. Okay. So today in blockchains, lots of research and applications has been developed, and infrastructures is focused on the core protocol layers and the consensus layers right here. Okay. Lots of companies have done this. And yes, this is work that is needed, and this is what we call the infrastructures right here. But later on, I'm going to also show a couple of slides. Why do we need to pay attention to the blue layers as well? Okay? Once you scale this, we're not there today. We're not scaled up here yet. Are they, is Ethereum or EOS or Ripple, or are they going to be the winner of the protocol like the TCP/IP or SMTP or HTTP? In the future, I don't see it yet. This is still a lot of work and a lot of improvement needs to be done up here. And once this is done, you still have to solve down here. Because this is a 40 years old protocol. Let me ask you a question. Have you updated your iOS or your Android recently? Or your laptop, Windows based? Update the OS? Sure, you've done that. And if your device is 2 years old, or 3 years old, or newer, you don't have to do anything. They'll upgrade it to you when you're sleeping at night. Just agree, press accept, and that's it. It upgrades. Try upgrading a 5 years old device. And even if you can upgrade a 5, 6 years old device, it takes you hours, and all of these good features and all of these bells and whistles that they put in the new OS doesn't work because your device doesn't support it. What happened here? This is all changed, the protocol up here. And this is not a 5 years old device, this is a 40 years old protocol down here. So, I want to present the problem from a couple of research that have been done. This screen is not good, but so yes, applying DLT in capital market is wonderful. There's a lot of potentials. Okay? You can transform new business, you can create new business, you can have new business models, and so forth. Right? Who did this research? This is 2 to 3 years of work that has been done for some of the most demanding applications for blockchain, which is in the capital market. Who did this? The first comment, the first 2 paragraphs is from the Japan stock market and Japan stock exchange. The second one, right here, the second comment is from the German stock exchange and the German central bank. Using the DLT and blockchain technology for the most demanding applications. And this is their finding. Okay. So on the smart contract bit, yeah, there is a lot of great potential factor, but on the smart contract itself, non-deterministic is a big issue on creating smart contract. So what does that mean by non-deterministic? So the same smart contract let's say if you execute this time, it takes 1 second, the next time it takes 3 seconds, right? So in the protocol and the consensus, that needs to be fixed right here, right? And data privacy, well, I don't need to speak about it, you guys all know that is also still a big issue right here. This is the 2 issues that I was pointing out over here. In the long term, on the long term side, throughput capacity is an issue. So, but before I go there, let me go back to the non-deterministic issue. This is on the protocol and consensus. If you go back to this slide right here, do you think this network today, the internet network, is deterministic? No. So if you solve the deterministic issue over here, on the smart contract and on the protocol, what about down here? Because this network is non-deterministic. So if you want this to work, you solve it here, you gotta solve it down here. So the next one is the throughput capacity. Okay, so this is again, it's a big issue, and you all know this is transaction per second of particular protocols. You know, some company can say I have 10, I have 100, I have 1,000 transactions per second. But according to this research right here, right, you are measuring the throughput figures through demonstrations. You're not saying, okay, I got one in Canada, one in Australia, I got all these nodes all over the world. Figure out the throughput capacity with the real node distributions, geographical distribution of node. So once you solve this throughput capacity, where is the problem? The problem is back down in the 2 layers again. Because when you run TCP/IP over 2,000 or more miles, and you have multiple sessions in TCP/IP, I give you the easy number, 10 gig. 10 gig packet. That thing will drop to 2 gigs on the throughput. Okay? So if you think that you solve the throughput capacity of this transaction per second, this is going to crash. Not now, because right now we don't have the mass adoption. That's why this talk is about scalability and mass adoptions. Today we don't have mass adoptions, but unless this reaches mass adoptions and scale to billions of users and devices, I don't want to see that happen. So I'm sure a lot of companies, from small companies to big companies, are all working on this stuff right now. But we're still at an early stage. So the most recent one, which is from October 25, 2018, from the German stock exchange, high latency and CPU usage is an issue too. So this latency is caused by the complication of that stacks, that change on the top layers, the green layers, right there. In addition to that, the network latency on the blue layers is a huge problem too. So that needs to be solved as well. And this is from some of the most demanding applications. Research and current findings and problems. So I want to take a look at this slide right now. Right? This is today's internet. So how do you solve the funnel? You have to change it into a synonym. It has to scale all the way from the application layers down to the system layers. Right? Remember I said earlier about you've changed your OS, right? I mean, look at this stack up here, and look at how it changed over here. It's application protocol consensus, and then you use an overlay network, which is very, very sophisticated right here, because you're changing from location-based addressing to content-based addressing, which is a very necessary stuff. But what does it do? It adds complexity and latency to the stacks right here. So the point again that I like to drive here is that we have to look at all these. Okay? So where do I think we are today? I think they're right here. And Splend, we have a sophisticated platforms for the social media that we're working on today, called the Integrated Blockchain Architecture 1.0. But at the same time, we're also in the lab working with 2.0, 3.0, that is an integration of hardware and software. Okay. This is already purely software, the 1.0, and uses the current commodity hardware and software, servers, routers that's available today. But we are working on 2.0 and 3.0, which is a specialized integrated platform, hardware and software, and you have a new hardwares inside to solve all layers. So the key is to cross to mass adoption. Are we here yet? No, not yet. So where are all the users today? Obviously, social media is billions of users out there, whether it's Facebook, LinkedIn, Google's. So this is where all the users are today. And I mentioned that at Splend today, we are 1.0 is we're creating the crypto wallets and the social media platforms and the communication platforms on top of blockchains. And we are actually working with the one of the largest social group out of Asia. And our program is we don't just build a platform and then try to get a user acquisition over there, and that's very, very expensive to do that. And we can't go out there and say, look, we're better than Facebook or Google and use our platform. That's not going to happen. And so we are driven by the community itself. And they have been wanting this for the last couple of years. Are they using the other social media? Yes, they are. They are talking to us about what they want, like for instance, directory memberships. How do you support the community? How do you use tokens to incentivize the community? So you know that the blockchains relies a lot on communities, and that's what we do right now today. Is we build this platform for a huge community in Asia. Okay, and this is another program that we're working with, but this is totally different. It's driven by so many different companies and government's involvement and so forth, which is a mass adoption in the broadcastings for the video in demand and televisions and movies like that. This is it's going to be a multi-year project right here. The one before this is actually we have to launch that in the summer of July. July is our first launch for the social media. This one is going to take probably another year or two. And at the end of the day, again, right, how do you reach the mass adoption? This is a huge project that I'm going right now, and we've been working on this for about a year now. Almost. So what I want to leave today to you is, in comparison between blockchain and the internet, right? Are we here on the application layer? The email equivalent of internet, I think we are, which is the Bitcoin. Okay? And what the email did for the last 20 years, since 1980s to 1990s, the email brings the density of adoption for the internet. You have email for 20 years before the Google and I used to be using the phone lines, so the email way back then. Right? So what Bitcoin did is, I think what email is doing is bringing the density of adoptions. Slowly, it's 10 years. It took email 15 years, so hopefully another 5 years, we will have some more adoption right there. Is the Netscape here yet? Now, why did I use Netscape? It didn't win. Okay, that browser. But the concept of Netscape was the first time in 1994, 95, right? That, wow, we need a browser. Right? And it takes a few years that Google, Yahoo came out after that, and then, it takes a few years before the killer apps started to come. And the Amazon, the Facebook, again, that comes after. But the Netscape really opens the door, opens the mind, opens the idea. We need that to, for the internet to be successful. So some people can argue, yeah, the Netscape is here today, or the Netscape is not here. That's up for discussions. Right? Now,
what would they say is the Netscape? Bitcoin is email.
I heard some people say that EOS is the Netscape. But I mean, again, I'm just telling you. I heard a very, very good debate at CES on this subject. And obviously, I don't agree about the EOS is the Netscape yet. So, what is the Netscape? It's very, very, up for debate. Have you seen it?
Yeah.
Okay. Who do you think that the Netscape is here on the blockchain?
Coinbase.
Is that?
Coinbase.
Coinbase. Okay, as an exchange, yeah, but they're going more than an exchange right now, right? So yeah, Coinbase. but they may not win. Right? I mean, that's good. They didn't win, and Napster didn't win either on music. So, but that opens up the idea for further development and innovations and creations and stuff like that. So, obviously, if this is not clear, I don't believe in these guys are here yet in the blockchain space. Now, let's go down to the protocol layer. These are the winners on the internet layers on the lower side stack. It's DPF, DPS, MDP, HTTP, and host control group. Who's going to be the winner? Right here. Maybe Ethereum. It's got a lot of developers, 150,000. Heather had a very nice presentation before this. Perhaps Ethereum will win. But Bitcoin maybe will stay, but it's not going to be used as a sexy technology like Ethereum or Ethereum plus. So maybe EOS, but it remains to be seen. On the network layers, we're still here right now. TCP/IP, and when was that released? January 1st, 1982. So give and take, the government was using it before that. 40 years, 45 years. And yes, it's been improved throughout the years, but it's still a 4 years. That's, I'd like to open it up to questions, and I think you guys can keep thinking about who's, are we here, are we not here, where are we? Are we in 1982, 85? Where are we right now? So I think it's, hopefully it's informative, and I'd like to open up for questions. Go ahead.
So with voice concerns around security, where would you say some of the biggest weaknesses and vulnerabilities as far as the security? How do you prevent that? I mean, as you see this.
Yeah, the security again. That is, that is a very very good questions because I saw in this later just a recent article that IBM Quantum computer is going to be able to break the 256 ECDS hash like that, right? So I don't think it's. I think that's the biggest, because talking about security, right? Yes, the wallet has been hacked, the exchange has been hacked, the Bitcoin blockchain itself has been hacked. It cannot scale, but it's very secure today. I has brought up the Ethereum Classic that recently has an issue, but again, perhaps it's a consensus or a protocol issue like that. So the security has to be done obviously in the protocol, and you have to bring it down to the network layer as well. So these are the two. You have to, security, like the same thing like the internet. You have security for almost all layers, all the way down. Even down to the chip level, you have CRC. So check redundancy check. So I think security has to be solved and looked at on some layer as well. Any other question? I tried to bring, not too much down, up, down, but that's the reality. One more?
So what's the evolution of TCP/IP? What is the next step?
Okay, the issue with TCP/IP is several things, right? One of them is that you cannot have an 80-90% throughput. When you have a 10 gig, you have thousands of miles, you drop it to 20%. So there are other protocols today that improve on that quite a bit. It's an issue of traffic management on both sides. You have to have connection oriented because you have to have lossless protocol. Otherwise, if you use UDP, you can lose packets. TCP is lossless, so it's connection oriented. But you keep retransmitting every time you drop. So it's non-deterministic because I don't know if I drop a packet or if I don't drop a packet, you got to keep retransmitting. So what is the evolution of TCP/IP? Well, we are working on a specific, like I said, the IPA 2.0 and 3.0, carrying from the 20 years of traffic management that we've done from the 90s to the 2000s in developing the internet infrastructures. We are working on a protocol that is, we have in our lab today. We can show a throughput between East Coast and West Coast of 90-95%. And we compare it side by side with the TCP/IP protocol. And one is a throughput issue. Number two is a latency issue. You cannot stream today Netflix when the file is in East Coast. The file has to be somewhere near you. So we are working in the lab today that yes, you can stream when the file is in East Coast. And what that does is it has nothing to do with the pipe size. It has all to do with latency. And if you remember, one of the current findings and issue that was posted by the German and Japan research after 2-3 years is latency. Latency is a big problem in blockchain. So we are working on the lab that if you can stream from East Coast to West Coast, perhaps we are closer to solving the latency issue in blockchain. So TCP has the latency and the throughput issue. And there are protocols and we're working on some. Yes?
So once you scaled and you have the new hardware and software solutions, then you feel your way of getting adoption is by bringing another social app.
The social app today is we're working in parallel on the applications. We started our company in 2016, and my other co-founders actually started even way earlier, personally mining Bitcoin, learning Ethereum, all the basic stuff, Solidity, IPFS, all the smart contracts, and building the expertise. Right? This is new stuff. 5 years ago, they were building the expertise, and in order to see the issues, I think you need to look at it from the user's perspective. Right? If you understand what the bottleneck is from here, then you can see what do I need to collapse down into the network. So, and at the same time, we have to get users to it. So, that's we are driven by a community, and this is an opportunity that we obviously don't want to ignore at this time. So, yes, we have a group that is working on social media side because it was customer driven. I don't want to say customer, community driven. And previously, when we built product, we always wanted to be customer driven because you already have a customer for that product. And so in this case, it's community driven. And but again, once this community reach 10 million, 20 million users, we're not happy. And it's doing all these transactions. I hope it get there in the next couple of years. And I hope by a couple of years we will have the box ready to that has specialized services and new traffic management to handle blockchain, true blockchain, decentralized blockchains in geographical nodes, not just in the lab demonstrations like that. And so, yeah. Am I good on time?
You're good. Nobody's told us to stop.
Thank you. I'll be around. Questions?
Yeah, it's part of the same group. Yeah. He's the funny. He's the yellow rings.
Is it sort of that we
Yeah, we have a demo, but we don't have a release.